Right, let's set things up. I like to change the appearance a bit so that you get a dark view. I think this looks better for everyone. So, let's so let this look good. Maybe I should notice if I can find it. Let's see if we can get some people. Okay. I guess it's time to turn down the sound. So, okay, so that was very, very abrupt. Let me set things up now. So, let's see if I can move things around a little bit. Okay, so thank you for tuning in. This by the way, this was something I added. So we have this always assert, which is a complement to assert, which is basically this is doing it all the time. And we should have some. I mean, this discussion on in Zig, like basically, I was on the Zig Discord and discussed assert, and some things came up, not for Zig, but related to that, and the fact that we're actually missing this always assert kind of thing, which is kind of convenient to just use because it's right. Basically, that's what assert will do, but it's always on. So I added that function, and then maybe we can do like it's easy for yourself to kind of implement stuff like a custom assert that just runs in certain conditions, but I don't think we need to do anything so like special for that. So anyway, okay. So what's next? Well, there's enums. So let's say you have an enum, right? Let's do enum, foo enum. Oh, the IDE crashed again. Good, right? And then we have a few of these. So you have like this, right? And then we want to do we start with maybe ABC, and then we want to do like, okay, let's add one to that, and then we're gonna add again and again, right? So we can also imagine that we, instead of doing like this, we just jump 2 steps. So we have like a plus 2 or something. Okay. So if I run this now, okay, maybe I should have done this different order. Sorry. I did have some optimization on the compilation. No, it was just slow to link. Oh yeah, I guess OBS is taking a lot of use actually. So here we go, crash in this one, right? If we take that in different order, it will crash because it's out of bounds, right? Because you start with ABC, like this already works. So then you get to DEF, and then you print that in this case, and then we want to have like 2 steps, and then you get like 3. So you don't want that to happen. And I actually already made an implementation here somewhere. Let's grab that from the shelf here, and you'll all see that it doesn't partly works, it partly works. So it's the wrong name there. But what happens now is that it actually will do wrapping. So we'll get some errors to this. So by the way, just go ahead and ask if you have questions. So here we go. It's a bit slow now. Yeah. So see that it goes here to, right? We have ABC, and then we print. Here we get to ABC. Here, right? And then we get to this, and then it crashes. So actually, wrapping here works. We could wrap with a big number, and that would still work. And in this case, what happens is that we're changing some things, we're rewriting this into something else. So we can just jump to that. We can also try, actually we should try this. So b is 2, right? And we can do 3, right? So then nothing should happen. So we are getting df, and then we get df again. I didn't test this, so let me just quickly make sure that it works. Oh, did it break? It did break. Okay, then I need to fix that as well. So we can just add, for example, we can like add asserts here. Now we can make this into our test case. So we're gonna assert that a is now equals to df, right? And then if we do like a plus equals 3, then in that case we should get still df, right? Because we just wrapped. And the same if we go back, we should get df. And then with this case, which is broken, right? We'll look at that later. So for now, look at this test case. So here we're just looking at, you know, going backwards. Oh, it fails in that one. Hang on. What does give us then? Oh. Like I don't remember. Maybe I reverted to something like partly working or something. Oh, did I? Oh, okay. I just have to look at what I did. Oh, it goes to 4. Oh, but it doesn't, like, does it go to 4 if I do like this? No, that works. Okay, so now I kind of have to figure out where these things are happening. So, oh, great. So we know that this part is working, right? So this is doing the right thing. And let's see here. This was when, now let's look at that, whether this one is doing the right thing too, right? So we can see where the assert failed. Okay, so our first assert to fail was really, you know, in this this equals minus. So let's jump at that problem and try to fix that. So we can have plus because that one is easier to expect that it works, right? We can look at what happens. So we are in the actually in the Sema expressions. There's a binary thing there inside of it, and we are here generally. So analyze Enum add sub. So that was the one that I changed. Enum add sub. Okay. So I was here. Oops, getting into this here. And what I was thinking was that that would work. Oh, recall that we need to fix the vectors as well. So yeah, okay. So in this first case where we get like a here's a sub, right? And we have the add version here as well. So actually, oh yeah, this is either is an enum, right? And then we go into sub, and in the case where both are foldable, we translate that into this code, right? And if it's a constant, we translate it into this with mod. I guess, you know, this one should be true regardless. So what you need is like, we are going to do something like this. So this, whatever mod we have here, this is a count. So you're going to do mod that count every time. So in the case where we are actually we do have two of them, then we are done. We can just resolve that. If it's like the right hand side is an integer, we want to do a mod immediately. Actually, damn it, we have two cases. We're gonna need that one anyway. Okay, so that we can move that one out of there. So this is the count. So it's already there. So in the case where we have a const int, right? In this case, we are we turn this into this. We basically do make sure that it's a positive number. And then you need to do this thing. Then you need to, you know, there's a positive number, so you don't need to add anything at the end. You can just do mod. But if we have the general case, right, we don't know that. So we have the right-hand side and the left-hand side, and we have to first, you know, we're going to do a copy of the inner thing first, which is the entire expression. So we do this one, and then we have to modify the outer expression to be binary open mod, and the left hand side is going to be this inner side, and then the right hand side is going to be like a I guess we copy the right hand side and then we update it. No, we get that. So I think this should be okay. This looks right. So now let's look at what happens in this case here. So okay, they failed. Okay, the type is grabbing the type from the type kind. Yes. So we are going to get like type lower, type flatten. I know. Let's say like type flatten left type, and then we're going to get like the internal one. So we're going to get like the decal enums and the type input type, so the underlying type. Okay, so that should be correct. Oops, I need the type kind. What's the language? I'm writing the compiler in C. The language is C3. So let's see how far I got now. Like the annoying part of this is that we need to do it for enums as well, but I guess the enums don't have the constant folding, so that's better. Okay, we get to 4 again. Let's see here. That's okay. Yeah. Okay, we should do. Actually, I fixed this one, right? That's the one I fixed. So if we have b and we want to print this, it should be fine. Like we can assert that a equals a plus b equals def. Okay, and assert also a minus b equals def. So that was what we wanted to. Oh wait. So this will not work. The first one will work. The second one won't. Of course. Let me just show you that. Yeah, so this one failed, right? So the way it works, so like actually in this case we could do it differently. We don't need the mod here, so we can do the add, right? And if it's, we could do like a ternary operation actually, which we'd lower to something better than this. It is a bit sad, I guess. I can't fix this here. It would be nice to fix this here in the yeah, I'm probably gonna fix it. So in this case we can have mod. Yeah, it's not gonna be as fast. Like you don't want that mod there. So in this case, first of all, we know that we've already reduced this addition, right? And we already if it's negative, we can just add until it's positive. So it's positive, which means that we can just have like a ternary here instead. So instead of this, we have like the expression ternary, and we're going to do like, how do we do this best? Now we need an extra variable to hold our value, unfortunately. Unless I introduce another expression. Sorry, never heard of C3, yeah. But I've coded in C2. Yeah, we can look it up. c3lang.org. Right. Okay, so we could do this with this binary mod. Like maybe it could like it's, if the sum is greater than something, I don't know, maybe we can optimize that later. It's always possible to make a small optimization for that later. Okay, we're going to look at this one. So for this, we are going to get, like, we have this binary operation, which is mod here, but it can be negative. Right? So actually, this is not good enough. So we get to have like inner 2 here. It's going to be a copy of again of this. And we can do two copies. It's just going to do it very, very simple. Just have the same span and so on. So we, in the inner 2, we have this. Like inner 2. And then we are going to get, like, the inner is going to be darn, it's not gonna work, does it? Is it? We need the ternary. We need a ternary here. We really do. That's annoying. It's simple to write as LVMIR, but it's not so simple here, basically. So I would say that maybe I should try to make this happen elsewhere. So okay, look at this right hand side. Right, we can make that const expr is now this I, right? And then that's going to be easier, and then we're going to do the mod in the LVM IR later. Okay, so that means in this case we're not going to do anything. Right? We're just going to go for it. So now we just killed off what worked, right? But let's emit this. So there's this LVM cogen for the expressions. So we're going to emit the add, right? So here we go. We have ints, which is it's going to be an int, right? And here we can kind of look at what it originally was. We need to know that's an enum though. So I had this as an alternative. Enum count or mod. Let's do that. And in this case, so if it has mod, it should never be here, right? So insert not mod. And then we can add this here as well. Okay, so in this case, we can have mod, and this like allow wrap. Okay, let's just, okay, if mod, okay, now we're going to do it slightly differently, right? So if we have like the if we have we can, yeah, I don't know. Oh, okay, wait, these are the ink deck. This is the wrong place. This is a different place, and I was working here before, so there's a problem with that as well. Let's just ignore that for now. So inside is a LVM emit add something. Well, some kind of emit add, but that's the ink deck. Where is the other one? Slice values. Here we are, emit binary, right? So we have the add, and so we are going to need to know what it was. So we can have, look at here we have the expression. So we can look at the expression type, kind. We don't have the canonical one. We might need a flattened one. So flatten goes past the distinct types, just goes into those. So we need to have that in case someone is creating a distinct type from an enum, and then tries to do this operation. It should work in the same way. Okay, so let's say that one is equal to type in. Thank you. So now we still want to add something, right? We know that's probably is going to be like we should be sure that size is not larger than the max, right? It should be depending on whether it's a constant or not. So we have these, different behaviors. Well, we can just do it very simple way, right? So we can actually do this, right? We have the value now, but if it's a type, if it's an enum, then we're going to have like LVM, LVM build rem something. It somehow I killed rem. There we go. So it's a urem or srem, doesn't matter because we are, well, it's going to be assigned. I'm stupid. Got to be no, it's assigned only if the thing that I have below as if I divide with something signed. That's the only case where that matters. So okay, let's see if we can get to where I was. No. Binary. And we were here somewhere. Binary. Oh. Where is it? Okay, here we go. Right. There's a pointer vector. Okay, it's not a pointer vector. We're doing that, and then we're going to build like LVM build urem. Right. Hang on, what's going to happen? If it's a negative number, we're going to add something. It could be a negative number. In which case it would be a large negative one. So let's say I say it's a uint, a char. We have, and I'm doing a minus, and it's going around. So it's a negative number. What happens if I do urem? Just do the same thing, right thing. I didn't think about that, but let's get. So we have the builder, and now we have a light right hand side. It's going to be a val, right? And then the right hand side value, which is going to be LVM const. Well, it's actually might be if it's a vector, it could be a vector. So if the left hand side is type kind equals type vector, in that case we should have like value rem. Decide that yet. So in that case, you kind of do a. Oh, we got to get LVM const int, and then we already have the type because we have this one, this value. Wait. Okay, we don't have that. We have the There's a vector type, left-hand side type. And then it's going to be like we need this now. Because in this case, we're going to need this, which is going to be like, oh, we need the count side. Count is going to be like flat decal enums values. This is the count. We're going to put it in here, and gives a vector. We're going to be like vector how to build a vector with a 1 or a number very efficiently. I know there's a way to do that. Well, let's put it to right. So const int is going to be like take the context, type, the count, and then when all is done, we can take the reminder. And then we're like, if it's, then we're going to be able to select. Will this be right though? Trying to think about this with a wrapping around small integers. Anyway, we can do the comparison. So build icomp. Oops, what the heck? Oh, so that, look at this. Can you see this? It totally bugged out. I think now this will happen all the time. Recovering editor state. Oh God. Okay, let's hope it works. So now we have the if I guess the result there. So if val or should I perhaps do the select before, right? I could do the select. I could do the reminder on the value first, right? And then I could get the like, let's just review what we have. So we have the case where, let's say we have 4 elements, right? And if I have 2 and just add, want to add 5, it should work for that. So in this case, of course, we get 7, and then 7 gives us 3 in the end, right? But you can also do like 2 plus 5 equals 2 plus, well, you get 1, right? And then you get 3. But then you do like 2 reminder operations, maybe. So you can do like A plus B, like this, and then plus B, no, plus C mod C, right? And then you kind of get around all negative values and so on, if I remember correctly, right? But this involves 2 mods. You didn't see? Oh, Bill, are you there? I just like had a look at this. All right. Hello, Bill. So Bjorn, yeah. I am. So here, anyway. Now I'm just getting curious if someone said no, send me anything else. Okay, so this one would always work, right? But that one is doing 2 mods, reminder operations, right? And you want to minimize those, and you can do like instead you can do like A plus B, the reminder of B, like this, and then like you do this calculation, and then if you see that B plus A is going to be like greater than C. Let me think about this. So maybe you want B. Okay, you can add C. Sorry, if you have that, and then you take the result and you add C, and then you add A. Then you get a range of things, right? So you can get like you get something either in the you can get like a maximum, you get like C minus 1, right? And then plus C plus A. So at max you get like 2C plus A. And minimum you get like minus C plus 1 plus A. So that leaves you with 1 plus A. That's A. Right. I'm thinking of whether there's a simpler way to avoid this mod. It's not very nice to have these mods here. But on the other hand, maybe, maybe I'll just punt this to the optimizer, right? So in that case, we don't need the select, and oh, sorry, there is a bit sound here. Then we just need this, right? We have the val, we have the build, this first one, this one, right? So we just need to add something to that. So val equals lvm build, build add c builder val, and then we're gonna have like the this rem. So we're gonna add that one. And we have, and then we do this again. And now it should be fine. Regardless of value. Am I right or wrong? What are you working on right now? Okay, you're asking me, I guess. We are working on wrapping enums. So that if you go add something to an enum and you reach the end, instead of having that being an error, you're just gonna wrap around it. So it's basically mod length. So let's see where we failed. Okay, so we failed at -1, which is expected, right? Because we didn't implement the -1. So we need the same kind of thing for that. So let's see here. We have that was the add, and there was the sub, right? And we have it for, there's a pointer one, pointer vector. Let's see, we're going to end up with the only thing being this one, right? So we want to do something similar here. Again, we have this one, right? So we are actually doing the same thing, right? Because it doesn't matter if you go back or forward, right? So we're going to get a negative number here in the span of 0 to minus 1 minus c, right? Something like that. So this is going to be a positive number anyway. So if I do this, let's see here. Oh, we get the flat. Okay, we already defined the flat here somewhere. Where's that? Oh, okay, we have. Okay, there is no scope. Let's create a scope. Let's create a scope for this. Only a scope for this one as well. This is like one of the things that I find the least ergonomic about C switches. It's natural because it lacks this implicit break, but it's still annoying to have to write that. Or I guess yeah, it's not super nice. I mean, you still have jumping over declarations in C. Why couldn't that work? You would think, but now should our, like, everything should work aside from the plus plus thing. Oh, the negative still did work. Why? What did I get? Oh, what was that then? Okay, did I do anything wrong with that? Let's print it out. We're not the best viewers. How dare you? Oh, yeah. Ban it. Another one. Sorry. Let me just boot that person, whoever that is. Okay. Whatever. It's already suspended, I guess. To activate it. Okay. So, oops. Sorry if there was a bit of spam there in the chat. Okay, so it failed. It got -2. Did I do something wrong with that particular code there? I just copy pasted the so we get a negative number here. And it seems like I might have. So we're getting that number, and we're getting the. Oh, maybe the URAM failed then. Right, what happens if the SRAM? Just randomly poking at things there. Okay. But that might do a bit. Right. Yeah, that worked. So because we have to handle this in like some good way, actually. Um, because if it's an unsigned number, it's gonna be like a huge number, and then do I ever like if hang on, if it's a negative number, what happens? Mm-mm. Hang on. That was some spam bot. I had no idea to say it. Yeah, some people are doing that. Hang on, I need to take a break because I hear my kids trying to kill each other in the other room. So I'll take a small break for like 5 minutes. It says currently it's what 7:25 here, and let's do it like I'll back in 5:35. Okay, so turning off the sound for a second. Let's see. Okay, I'm back. Let's see if someone. Uh, okay, math looks correct. Mathematician. Um, anyway, we let's see where were we. So, okay. Um, illegal value. So, okay, so we got like the problem is I'm like thinking about when the enums are unsigned and you have 256, then you need to do the help me out there. I'm like blanking out. Someone write something. Look. How much do you need to add classes to C3? Funny guy. But seriously, how do I fix the possible overflow here? That's a problem. Like imagine we have 254 entries. We're adding 6. Now we end up with 4. Hang on. It's 256. Yes, 4. Number is 4. Right? And then we see that as the result, right? Because when we do the rem here, it looks right, but it's actually we are doing the reminder on. It's 20.4. Hang on. And I'm saying it's. Yeah, it will give you to 4, but let's say that is the number we should have 6, right? Yes. There's the. I don't know if Bill is still there. You can probably remember this. He's probably done this. But I usually do like this, right? Now the problem is the overflow, especially like there's a maximum enum size somewhere. Enum max size. Max enum. Because then we could say like if it's we could always promote it, right? We could always promote a char into a short and a short into a Because what essentially happens when we do this is that you get first the mod 256 and then you get the mod 254, and they're going to give you different values. Sorry, it's going to be like this, but anyway, it's 254. You add that, you should get 5, but in this case you will get 3, right? So I guess I guess if like, I guess you can look whether it's, I mean, you can't really figure it out from this, right? You need to do this already with one step up, and it won't be correct. Like if we do the mod first, of course, if you do the mod on the RHS value, we're in a slightly better position, but not great. Like you could, if I could do the mod many times, then it's fair, fine. Let me just Google for this. Right. Because yeah, like I can't think right now. Hang on, does that maybe? No, it doesn't work, right? So. Hmm. Well, I guess we're looking at having to widen it. Which begs the question whether it can work on bigger than int, but we can always. Okay, let's do it like this. So f flat. We have to do it here before. Oh, that sucks. Type equals type enum. Okay. So because we know we know one thing here, is that if the okay, so if the VM type type size somewhere. LHS type. Okay, so if the bit size of this one is a little less than 32, then we can widen it. Then we widen and just go for it, right? I'm just going to widen it to 32. Oh, this is such a pain. Okay, let's see it. Okay. Mid there's some trunk or something. Mid trunk. 6 trunk. Okay, in this case, I would like it to. I don't even know if it's negative. Oh, okay. So if it's signed, this is getting so complicated. So if it's signed, we are going to like extend that type. Trunk, right? Build extend. So we are building this. Is signed. It's and now I need to figure out what it's going to be extended to. Okay, so we have the value. I'm just not going to do anything about it. Oh, we forgot the type. So the destination type is going to be like type int. No. Shards type, vault type, type ID, winter type, no. Guess I'll have to. So someone said hello there, yeah. Wait. Now it's not, might not be an int. Like this is not fun. Just yes, okay. Okay. If it's a vector, then we get type, get vector, and then we are going to get like what we are getting the type int, and this type vector. No. Use array length. Yeah, otherwise it's type int. If it's not, then we get. No, we're gonna get this. Oh, damn! You're gonna get this anyway. So we're just going to do different things. Type vector is gonna be say like what the vector kind is and take that. Okay. Oh, you're not going to look for a vector, it's going to look for type is vector. Because we have two types of vectors. So. In that case, we get the type, we get the kind, and we get the length. And then we're going to extend it. So LHS value is going to be like LVM build X. Now we're gonna look, okay, we're gonna look at where it's signed or not. Type is signed any, and looking at the LHS type originally. Okay. You're gonna get signed type eventually, but not right now. It's okay. A lot of work to get that, you know, this wrapping. I just feel that there should be some simpler way to do some maths and find some better solution there. Okay, we get to vector, and then we're gonna do signed. Right now, it's like not really giving me any completion at all, which is that's next. C builder, and I'll take this this value, and then it's what next we need a destination type. Get C LHS type, and then I think we just need some comment on that one, and do the right same thing here, right? And we are just origins. We have the same type. Okay, so now we kind of widened it a bit. Of course, we're going to need to eventually make it smaller, but I will do this, right? And then we're going to do the whole thing. This. The worst thing here is that we need to do almost exactly the same thing with the add. But okay, let's do this thing. We're going to add, you know, okay, we are doing the rem. Actually, right, now we can do the srem safely. And we can do the urem, and then we're going to do like val equals, and then we're going to build this truncate. Right. So let's do it like this, maybe. Otherwise it's null. Right. Actually, we'll go in here. If we extend it, we're doing this, right? It's all this, and in the end, we are going to like this, okay? And we're getting this new one, this new type. Apparently, there's something missing here. Destination type, value type builder. Oh, it's signed or unsigned. Drop the unsigned part. Right. Essentially, same thing, but you here. Gonna add that soon. Try to not forget about it. It is not looking particularly elegant, does it? No, it's just zero extensor. Okay, and then we get that particular value, and I probably did something wrong here. Did I? Left hand side, right hand side value, and the right hand side value. So now these new values are going to be fine. We are going to do this whole thing, and then after that we need to truncate. It always feels so, you know, iffy to do this, but okay. So we have val. We take the value, and then we have like the type, which is going to be like type get get type. Sorry, get type, and that's going to be like the original type. And we're done. Right. we can actually, let's see here, we can break here, right? So then we're done with enums, that kind of enum. If it's not, then we have some another, like if we're not having this bit size, which is smaller, in that case, we don't do this, but we need to do this mod, sorry, this RAM on the type before we go into something like this. So we're going to do this thing. Let me get the reminder. So rather than doing this, we're going to start start by getting a sufficiently safe value and then do the reminder on that one. So if we take like we're going to do, eventually we're going to do this sub int, right? So rather than changing from unsigned to signed, which is one thing I could do, is that we are going to start by building the reminder of the right hand side. And then the reminder of the right hand side. Is that true? Now it might be that one side is like, we have to assume that both of them are in bounds or something. Do we need to do that? Well, okay. We are going to like look at what we had to do to make that work. It's not pretty. It's not pretty. So this is kind of sad. Oh wait, the reminder is the wrong type as well, right? It's not going to work for vectors yet. So depending on whether it's signed or not, we need to grab that. We need to know if it's signed or not. Okay. So if it's unsigned, if it's signed, okay, it's signed, then that's a little easier because we can just start by doing this on the right hand side, right? And it's just crazy at this point. It's just bonkers. Maybe I shouldn't allow this. I know. Maybe it's bad. Okay. So if it's signed, we can do this on both, right? Like if we knew to a negative or something, we could just swap the sign to the other one. Well, we can always do this, right? We can always do the reminder. We know now it's in. It's going to be like fit. Actually, when we do this, it's going to fit, right? This is going to fit whatever we have. When I think about that, because there is not going to be 4 billion to even 2 billion enum values, right? That's not allowed. So we can then do this, and right, and if it's unsigned, what we're going to do is we're going to add to both of them. So we're going to do like right hand side value equals LVM build add actually no unsigned overflow, because they shouldn't be possible to no unsigned add. And we're going to be add, right hand side is going to add rem, just nothing. Okay, and then left hand side that's also going to add this. So now actually we can just don't do this, right? It's better if we don't do that, because we're going to subtract this, like I don't know, what did I do? Yeah, so we're just going to add seed, this like the reminder to this, so then we are sure that we're going to get a positive value. And in this case, doesn't matter if we do that or not. And then we do the actual subtract, and then depending on whether we are signed or unsigned, we're going to do like if it's signed. Actually, this is interesting. So if it's signed, we're going to do like, we can do this, and then finally we have to do we're going to add to, hang on, maybe like if I add to both, right? If I add to both this value, right, it's going to be positive. So now everything is positive here, and here everything is positive afterwards. Now we're going to, okay, so yeah, no, this doesn't work. This is going to be positive, but that might mean it's negative, right? So we might start with a negative. Might start with a negative value, yes. This can never start with a negative value, so we're like, it's different, but this will then start with a positive value, and this will be a positive value. And if I take like the reminder and do it twice, it can always be good. So we actually gonna grab another of these. I want another one. So we're going to get so like count times 2. So if I add that one to here, we are always going to get a positive value of this. We always just need to do the reminder, and it can be an unsigned, since we're getting positive values regardless. Okay, that should be okay. Okay, let's review this. So if it's smaller, if it's int I32 or larger, then we do this reminder operation, which gives us a value between minus reminder -1 and positive, the corresponding positive. Then we add to both, and so both are positive, except this one is at least the reminder size, and this is, hang on, is it, if it's negative to start with, maybe I just add 3. It doesn't matter because we can do whatever we want. Maybe I just, yeah, maybe just 4. So it's going to be positive. So this is positive, that means, and this is always positive. And the addition, because we add this thing here to this reminder, we're going to get the positive result when we do the negative, this minus here. So now it should work. Let's compile. What does BE stand for? Well, it's backend value. Basically, yes, backend value. I probably just wrong, like remember something wrong. But let's try it out. Damn, it's slow when, you know, OBS is running. Okay, we got something. It still fails on this one. So why do we get a negative? Let's look at the output here. I feel like every time I program on like live, it's adding some feature like this. It's always, whoa, I've got a lot of stuff here. Well, it always kind of fails. That's what it feels like. Okay, so we have the A minus B here somewhere, right? This one. So there's an assert somewhere in the source code. There should be some sub thing. Here's the add, I think. Okay, those are the, okay, assert okay. Right, here we go. I think. I know that's the old one. So that's the normal one, I guess. Let me remove the other ones. So that's easier. So that's easier to kind of look at this code, generate the code here. So now it's going to be like the last thing that happens. It's going to be like calculation that we print out. Actually, I wouldn't have thought of this being an error if I hadn't done it this way. So it's for the best. Okay. Yeah, we are getting that towards the end, right? So God, that's a lot of code. Yeah, and unfortunately, it's like the panics are taking a lot of credit for those fails. Okay, here we go. Assert, boy. Here we go. Okay, so we grab those values, right? No, rem add. That's still that assert. Okay, and the assert fail, assert okay. Then we load these and then we wait. Did it just skip all my code? Oh, wait. What? Okay, now it should work better. So I have to test this later with like a lot of a very big value. But okay, let's go. Let's go. Here we go. -2. What does the code look like? Right. Here's the sub. Here's the what. It doesn't seem to enter this code path. Or I did something wrong. Probably wrong. Yeah. Something is wrong indeed. We're not getting this code to run. Which doesn't make sense to me. What happens if I put this to uint? I should force that code to run. Now it runs. Okay. Now when it's uint, it fails. Okay, yeah, it was some things at the beginning here that might be wrong, but okay. So we are like, let's do this without further ado. Let's do this and print that one. It's only, oh, I forgot the B. So it gives me -2 still. Okay. Yeah. So let's see. Where do we have that calculation? We store B, store A, la la la. And we add to A. And we print it, and then we're going to do the assert at the end. There we go. Here's the assert. Okay, assert. Where's the rem? Here we go. No, urem. Again, it's like it's never called. Nope. A minus B is never called. Oh, that's exciting. This actually works. So is it running this code now? Yes. Okay. I'm somewhat confused as to why it didn't work the other way around, but okay. So it's assigned. Why did the cost make it stop working? And then we get all this stuff. Okay, yeah, that makes sense. So that one worked. Let's see if I put like a huge number there. Like minus u int max minus 1 or something. We'll still give a val number. Oh. Any questions so far? Maybe I cropped that my portraits too much, too aggressively. Yeah, so that worked. So we're going to test something, some other path. So we have these, right? And so we're going to add, you know, plus 254 to this one. So like, will this work or not? It did work. If we take minus the same amount, it should give us exactly the same. Oh, the other one was plus, so it would just use different code. Oh wait, did it fail there? Yeah. Right. Bit width must be the same. Okay. So look here, I created that one from the old type, right? But in fact, here I need a new type, right? So that makes perfect sense. In here, we are instead like, once we are here, we can have, you know, the reminder, which is the same, blah, blah, blah. Get here. So now this should work. What amount of crap I do just to make this work. Like, I really hope this can be optimized away, otherwise it's like horrible. So yeah, it gives us the same result. All right, so let's perform this while vm mid enum add sub, because we need to extract that code. We need to make it correct for all the different cases. So we should leave a value ref or return, and we are going to get like the value ref left hand side and LVM your right hand side. We're gonna get like type lower type. No, it's just type. Oh, it's a lower type. Sorry, lower type. Type. And bool is sub. Okay. Oh, it should be the other way around. Type says blah blah blah. Here is so true. True. Fun fact: there's a name Ture, which is a Swedish name, which is Ture, basically. So people have that name in Sweden. Okay, names were changed clearly. Okay, we need the enum values as well, so we need to count. Count as well. Okay, so we have the type if it's signed. Bit size is small. If it is, then we grab ask whether the type is vector. Get the vector type. With a constant. I wonder if the constant can handle vectors. It can't. So that's a problem, but where is that? So enum count. So now the left hand side is this. Sorry about that. And the right hand side is this. And if it's smaller, then we're fine to do whatever happens, which is sub. Then we emit this. Oh, we need location as well. Okay. So we have source lock. Okay. Right, new type is probably a better name. Okay, a new type. Since we're already getting that new type, why don't we make LVM type ref new type equals or no questions. That's kind of boring. You have to think of new questions. Const int okay, and now I have this. Both of them. So Wait, and if it's a sub, then we're gonna have this. Wait, the type's wrong here, right? New type. And we're gonna get the lock, the source lock ID, right? So it's a source lock ID, sorry. Otherwise, it's an animate add int c new type left hand side, comma right hand side, lock. Okay, and then in the signed case, or if it's a sub, if it's sub, it can, and it's let me think about this for a while. Okay, so if it's a so if is signed, then this value might be negative. So we need to do these. We're going to need to truncate in the end, right? But we need to do this because the value might be negative if it's signed or as sub. Okay, so those are the cases where it could get negative, right? Then we want to do the reminder, then add, and then we're going to do a reminder again. If it's unsigned and it's an addition, we could never get a negative number, so we can just do this, and then we finally do the truncate true, right? And then we're done. We return here. So then we get the other, the other way around. Then we have the reminder is the Enum count. So we have get type. It's the type. Okay. In that case, it's signed. Now we are building this. We have an integer or something like that. So we start by doing a signed reminder on these. And then we create an addition here. So we are taking, like in the case of, like we don't know what the numbers are. We don't know if we are going to add or subtract for this. So we're just going to make making the first number more positive than the other. So that's what I'm doing here, right? So we are going to, regardless of whether we do add or a subtract, we're going to get a positive number. And in this case, we are always kind of getting a positive number again, whether we, if it's, okay, we only need this actually. If is sign, okay, so if it's sub, that's the only time we need to do this, do the reminder for unsigned. Otherwise we'll get a positive number in the end. So, and then we finally do this thing, this addition or addition or subtraction here, right? And then we do it with the type. Because here we know that, like we already fixed the wrapping. We already did that up front, so we already did a mod here. So in this case, we already know we won't overflow, it won't overflow. So now it's just going to be, perform this sub or whatever, and then we can just do the reminder and can do it with the unsigned because we know everything will be positive, so it can't be wrong. Or I shouldn't say it can't be wrong because we can have bugs, but anyway. Enum rem. Then let's call the other one. Okay, so there we go. Now we're gonna have to add this to the subtraction as well, and then we have to do the vector version. And this is not actually fixing the last problem, but we're getting closer to the problem. And wasn't it lock first? Was it? It was like lock enum count. Lock. Where's the enum count? Okay, flat. Enums. Oh. Back size. Flat enums values. Something like this. Oh, take first. Right. And then we're done. Break. So we're going to have something like this for the add as well. Here we go. Again, we're going to do it there. I need to have this flat thing here. We are going to say that it's false. Great name. Well, you guys can use it here for like a trick. So, okay, this should actually do it. This should actually implement everything. Let's see. And then we can just, add back all the tests that we had. If it works, if it works. Okay, so, right, so this should be, working. Remind ourselves, look at the vectors. But we should get to this and then we'll start, wrapping, and that's going to fail. So let's see if we get to def there and start getting errors when we're wrapping it and printing it. Okay, so, oh wait, int cannot implicitly, okay. So we should get char there. So. Okay, so we failed somewhere. Okay, a minus 3 didn't work. So we ended up with 0. That was weird. Like, does this work? This is just -1, right? So it was df, and then going one step back would give you 0, right? No. So it gave us the other one around, the other way around. So let's see here. Here we go. If it is a sub, do sub, right? And then if it's that is the small one, right? So why is it doing the sub every time? Okay, so we have okay. So A here is ABC, and we add, and we pass this, and we no, okay. Where do you fail? This seems to have passed, right? The +1. And should be DEF. Right. So okay, we get to so like which one is wrong? It's like this one, right? Now it kind of works, but I don't know why. It should have been like A is DF, but then we get like DF again here, even though we seem to have modified it to be -1. And then I don't understand why the other things work. So, okay, so I do a -1 and I still get the same result. That is not good. That is very much not good. Okay, so we could do perhaps stop it here. Like I feel, aren't you bored now? It's so slow. It shouldn't be this slow. Okay, let me see why it fails. This is such an annoying feature. I feel like pulling it out just because, but actually I love this when I use it. So for that reason alone, I think it's probably a good idea. You end up using it, and you can't do it generically for all enums. That's the problem. Okay, so let's see here. Assert fail. Maybe I should just like implement inc and dec instead, like next or previous, because that's actually what you use, and not have this wrapping for the numbers. That would simplify the implementation by quite a bit. Because like if you just have like, I wanted to have like plus plus and minus minus, but then the whole thing with, you know, adding, maybe I can remove that. I mean, look at this. Okay, so viewers, wherever you are, Like think about how you want to use enums, right? So let's say we have this enum. I don't know why. Okay, it fails because of this. Two nested ones. So let's say you have this, and you want to go like, how often do you do this? Now, if you say that no, this is not allowed, then things gets much simpler. You know, everything is simpler. Because what happened? Well, if we just say, okay, only this works, and this one works, and those are modular. But the problem what we run into is like people can write whatever they want here, right? So A equals this, and then have to make tricky things happen in order to make this work. If we say like A++, what we can implement that as is basically if A equals basically A equals foo enum length. In that case, return ABC. Otherwise, return basically this foo enum. Make the int of this A, or maybe do A ordinal, right? Ordinal plus 1, and then cast that one to foo in, right? So it would just be this code. And it would just work on increment and decrement. So if you want to do like, oh, let's go to the next state, then you absolutely do this, not the general let's jump 2 states or something like that. So maybe I should just roll back this and add like an error on doing this, right? Instead. Because, like, to be honest, this is the feature I want. Or, it could even be next, right? So, like this. Then we could just, we could just define every value in a value naturally has a next and a prev, right? You don't even have to calculate them, but, well, you would get like this. So you can get, okay, a next. It's a look. It's just a value, right? It's not a call or anything. And then you have next this one, right? This one would mean let's mutate it, right? So you could always have like A equals A next, right? A equals A prev. Because you might want the next one in the line. Or you just want to do A++ and A minus minus. Like maybe, maybe those two are enough. What do you say? Because this codegen is crazy. I mean, I haven't gotten it right yet because it's trying to fix so many problems. And I'm just like, why am I doing this for a feature that is essentially not something I'm doing? So let me show you something here, I guess. Like, I think I probably have a something like dot length. Okay, so it should be something like okay, I'm Let's see if we can find an example of this when I actually use it. Because the object here is not to do a general any modular kind of calculation thing. Oh, it's not here, but I can show you from elsewhere. Okay. Yes, pulling out some another editor. Sorry. So it's the question whether you want to skip several, right? But then you can always do that if you need that feature. You can do that, but if you just want to, like in most cases, at least for me, the most common case would be to just increase by 1. Right, and if you want to increase by 2, you can run this a++ twice, right? But well, can this load? I think it's unhappy with me using OBS. So let me see if there are any questions in the no, I don't think so. Nothing in the Discord. So no. Recently, I discussed in the SIG channel this thing with asserts. While I'm waiting for this thing to open, now, PHP Storm, did you die on me? Yes, you almost did. Okay, it's dead slow right now. Okay, let me see if I can find some advent of code. Because I do this on advent of code. Okay. Now trying to load that project. Okay. Dot length. No, it's just okay. Hang on. I know why that might happen. Okay. Yeah. So, for example, I would write something like this. Here we go. Right, with direction being defined as. Grab that. So I had this Enum, right? And I wanted to go to the next, turn right, basically. So here it doesn't work, but we could imagine it just did like this, and we just give it the next one. So we walk around this because we don't want to iterate over we're kind of turning all the time, turning right or turning left, and that's when I use it, at least, and when it's not there, it's kind of annoying. Let me see if I can find some other example of this usage in my examples. It should be, maybe it's like length somewhere. Let's see if I have something here. Yeah, here's a snake, right? Again, you see you turning, left and right here. And also, like in this case, we are getting mod 4, right? So we're always using the positive values here. Let's see if I can find some other example. Now, obviously, it's something like directions when you kind of go to the next one, or just here are, we're gonna loop through all the camera options in Raylib, some Raylib example, and again, we just, we don't loop through them, right? You have this list where you go through it. So it's already in like 2 examples at least here. But we notice that what it does is that it always jumps 1 step, right? We just want to get the next one every time. And if we don't want to do that, we can still, jump and go for the go for something more complex. So that means basically that I should get rid of this. So let me kill off some things that are maybe taking some CPU time for me, making everything slow. Oh, there's an app store open. That was very necessary. And so there we go. And maybe we can even close down Xcode. So what I'm going to do is I'm just going to, I don't know, throw it away or shelve it or anything, something like that. Because it's, what I realize here is that this, like, it's too, if it had been cheap, right? So if it had been really easy for me to implement this, and I wouldn't have, because I didn't, in the beginning, I was just thinking about the plus, like the next and prep. And now it's kind of, maybe I can implement the next and prep after this, but I'm definitely going to want to remove the add there. So I don't know if this is breaking anything. So let's shelve these. So uncommitted changes, shell changes. Let's call it mistake. So the first thing we want to do actually now is something else, right? So the first thing I want to do is disallow this. So I don't know why this was allowed or what I was thinking, but we should disallow this now. So let's see why if it works, it could be that I made a mistake and it's not broken. You kind of want to do like the difference between 2 enums, right? Okay, D. Okay, D. You want to make the difference between two enums, but do you want to make the offset? No, you don't want to do that. Okay, stole syntax, which is not recognized by the IntelliJ plugin, which I've been working on, but it just refuses to compile thanks to the Kotlin stuff. Oh, it's yeah. It's this thing. Okay, let me just drop that. I don't need this thing right now. Right. So this works, but it shouldn't. So Sama add, add binary add. Add. Okay, so we are here. And then we have the assign, right? Blah, blah, blah. I'm going to analyze with inference. And then we're going to have this add. So we're not going to, you can't subtract an enum from a value, right? It should only work like it should only work if both are enums, right? So let's just do it like this first of all. Okay, still kind of worked. Why did that work though? Oh, maybe you can just do it's might be different. It might do this implicit conversion or something. Cannot do the addition, yeah. So and left, let's see here, the operation should be, oh, it's an add, then it never works. And if it's a sub, then it can work a left type, and then we do like the analyze this, and like we're changing from this. This now we're getting like the difference between those, and we only do this, I guess, so we can get a diff. Do we even need that? Like, do we need the difference between two ordinals? How far they are apart? Can't you just get the ordinals? I think you should just get, like, make it simple. Why do I have this? I don't think anyone is using it, by the way. It's just something there that I thought was a good idea at the time. And I don't think it's a good idea. Like, it was, maybe in the point where I was, trying to make it work like constef. Where constef people kind of make these kind of things. And you want to have the difference between it. So we can't do the addition. Good. We'll be able to do this though. So like, if this is allowed, then it's broken still, right? Yeah, this is allowed. Again, it shouldn't be, right? So Sema now is like a sign. Analyze sign. Oppa sign. So now I have this. Okay. and it's an identifier. All right. User defined. So we're getting that. It's numeric. You shouldn't take the enums. Right. Type I underlying may add sub. Okay, let's not have the enums in that group. We're not doing that. Okay, and right, so now we have like op enum pointer. Okay, then we can skip all of this as well. Right, and then we never have an enum, right? So, okay, we can change this one and remove the is enum. Right, so now see what on the left side is. Pointer. Two times always this. Let's see if there's something else. Okay, you know, when the left side is pointer vector. So you can't really do any ops with the vector enums, but we can convert them. Should be fine. So now it will be, you know, unhappy if I do everything and anything else. I'll just check that I can convert a vector of enum values to ordinals as a vector. Let's yes. Okay, so yeah, so that's fine. Let's just see if I make a I can do this. I don't think this is like tested well. It's north and east. And then I want to convert this into no char. Char2. This should work. Let's see if it does. Because then you can kind of, you know, grab the ordinal and then go back and forth between the two. Yeah, you can do it. Because then you can just do like v plus equals 1, right? And then we can do, you know, v equals dir 2 and just go by way of the numeric types. Like I was generous in terms of what you could do originally, and boom, something fell. So cast vec to vec. Okay, let's see what happens here. Ah, right. So if it's like a type is okay, what happens if I do like case enum, right? Type enum. Type flatten to int. Will it flatten the enums? No. So let's set 2 enum equals from element. Okay. Expression rewrite trunk. Let's see what happens here though. Two element. Let's see if that works. Yeah, so now we're kind of good, right? So we can see what this was as well. So we started off with 0, 1 there, probably. And then we add 1 to each of those. And we end up with this east south. So this is working fine. And that's good. Because like maybe we don't want to, you know, have that W++ thing working. It just, let's just make that work on the this wrapping on a single thing, right? So we still have this, right? And we can look at whether this works, right? It shouldn't work, but we can see if it works. Okay, so we kind of want to avoid this, I think. But for now, I think I'm kind of happy as it is. Yeah, you see, it kind of works. But I don't see much use of doing this. Maybe I should. Maybe I should keep it. Actually, do it with on the entire thing, right? So let's see if there are tests that actually handle this and maybe something breaks. Meanwhile, ask me anything about this, what I've done so far. So basically implementing this made me change my mind about whether I should keep. Hang on, just going to need to change this filter here. Let's see if I can do it. Nope, that was it, not it. There's a filter here. I use it to kind of crop a bit. Maybe it was a little too aggressive. So whatever. Yeah, I should do this. So there you go. And now it's getting later here, so it's a little different color from when I started. But this game, right? Hello. Okay, so right now we're running tests, seeing if we can, you know, this looks good. So I started out adding features, and now we're removing features. So let's talk about C3. General, what's happening. So what I did recently, of course, was working on the matrix parts, which felt really good because it's been kind of broken for a long time, and now suddenly it kind of works. There are there are some interesting things being done. I think like there was this idea. I sent this by I don't know, remember the name, no knows and something, with a new organization from the libc, right? Unfortunately, when I worked on that, it was like the names were not unique enough, meaning that basically those would be mismatched. Like if you use that, if you use libc, include libc, your code might have collisions. So you don't want that. But otherwise, there was a nice idea of like having things organized into headers. But then eventually, you kind of, if you do it like that, then you might indiscriminately add parts of libc. So it definitely needs some organization, but I think not everything should be in there. It's mostly for things that you like end up needing. And I notice that people end up like, oh, here's libc, let's use that, when there are perfectly good things that kind of match C3. So they're like, oh, let's, I don't know, use atoy instead of toInt. Whereas atoy has this problem of when it fails, it just, it just returns zero. There's no way to get that information back, and there are, then there's the other versions of it, to whatever. So you have these, and then people use like atoy, libc atoy, and then they complain like, oh yeah, I wanted to use this function, and I have to convert the strings to z string. But in the first place, it's like if you're converting C3 strings to Z string in your normal code, then something is wrong. I don't know. Oh, there's like the screen is kind of bright right now, and I'm like, whoa, I have to turn on the light in the let's see if we can have I save remote. Oh, it got really dark. But anyway, so people by mistake that use the libc versions because they don't find the regular ones. So we through yet? Are we getting through? No, there are some things, right? So we have these failing enum plus minus here, which is failing, which should be failing, right? Because I just killed that. So now there's the question like, do you want to keep this or not? I should, before I check this in, I would obviously need to check with people whether this they are using this or not. Right, we have the ink assign, which is also doing the same thing here. So there are some Hinamad Sabya. So all of those are just broken now. On the other hand, I don't think it's like, it's written anything about this working. So I'm actually gonna do, I could go ahead and basically do a poll and see if people are using this. and subtract to enums to regular enums equals depth. Are you this? No. So let me add this to a poll here. Oh, that's a programmer Dan. Okay, like let's. I'm gonna take and write a poll here now on the Discord. There's also a discussion whether we should abandon on the Discord and go for something else because Discord is doing bad stuff. I use my enum minus my alpha enum 2. I use my enum plus 1. Let me add another answer. Okay, so let's post that one. All right. And let's poll voter. Right. If I don't see anyone using that, I can pull it out. Otherwise, it has to stay until 0.8.0. I would like to actually, delay that one. This 8 point. Let me just put this elsewhere in my local unlived branch. Let's call that KL Enum. Right. So just commit. So okay, 0.8.0. There's not enough breakage yet that I want to introduce. That's my biggest problem right now. It should be like 0.8.0. It's scheduled for the 1st of April, I believe, right? And it's now the 20th of March. So really, it should be time to go to 0.8.0. Like we could do it, and there's a lot of stuff that will be cleaned up and removed. Definitely deprecated stuff that will be removed. But at the same time, there's nothing right now that's not possible. We could continue a few versions of 0.7 and it's kind of, I don't feel really ready for 0.8 right now. I'd like to have some more iterations. So be aware that I might just delay 0.8, but we'll still get like the 0.7 point like monthly releases. It's just that there's not enough breakage yet. If this would break things, maybe I'll just pile it up, right? Like these enum changes, and then that will go into 0.8. But it would be nice to have something else. If something like a big thing that needs to be changed, that should definitely go into 0.8.0. Yeah, so yeah. So any questions now? You have like I feel things are, you know. So okay, yeah, I was like, I know Manu here was writing that he had to think about that poll, right? I don't think most people know about this iterating over enums, and to be honest, I haven't seen, like, the only time when I've used it myself would be when I wanted to do this thing where I want this to actually wrap around. And if I never use it, then that's usually a strong suggestion that I should move it. You saw there was quite a bit of um, of boilerplate go. Actually, a lot of code that had to go into to. So people are voting randomly. uh, okay. So doom. Yeah. We're currently almost running the whole unit test on the browser via EM script. Temp allocator giving me some issues, but I'll find a workaround soon. Okay, that's really nice. It's the temp allocator has some disadvantages. It has to be thread local. Just otherwise, it wouldn't work. It has to be. You can't pass around. You have to scope it, right? And the scope is basically in your current thread. So you kind of have to think about how you use it. But if you use it right, it works. But it can't be used indiscriminately. So that's one thing. The thread local is a bit gnarly, and maybe we can do something nice about that, because it doesn't need to be like right now. It's emulated by LLVM. So it kind of generates these thread local variables. And the nice thing is that it will be then compatible with thread local on C. So that's nice. But on platforms where that's not a thing, then it's just like a little less nice, I guess, because you're not actually maybe using C on the other side. You might not have Clang, you are just using JavaScript, and then it's different. That's a kind of different story. There is still, the dynamic dispatch, which is kind of a thing that I would love people to um, to uh, think about like, can we do the way it works with dynamic dispatch is that it has to register somewhere, someplace. And right now it's kind of doing that at load up. So when it's loading things, it's gonna put them together. I'm looking for ways to kind of do this without the overhead and without having to run anything. This init is very annoying, but has to take into account that we have like dynamic libraries that will load, and when they load, they will actually need to register their particular things. So like their particular dynamic functions. Oh well, yeah. I don't know why I randomly thought about that, but I need help with getting each platform really up to date. I think like on macOS, for example, for that actual example, we, instead of doing init things the way LVM does it, it just creates one single init, and then it puts everything into two sections, dormant sections, and then we have a runtime code in the standard library, which kind of goes into that particular section and start loading and running that, and that's the only thing that will run and start up that particular code. And that will register a hook that will do the same thing when some dynamic library is loaded, and it's not super checked, right? And that might have bugs and stuff like that, but it's the thing is that that code that does this could be invoked, right? Unlike the Linux solution right now, which is kind of relying on these constructors being run in a specific order. We could do something like that on Linux as well. We put them in sections, and then we have to do that in NetBSD and FreeBSD and so on, and then we will have similar things with Vasm, and that would probably be the best, so that you have like this init thing that you're running, and then you can call it from elsewhere, and then it will always initialize the dynamic lookup. And there are some optimization options there as well for dynamic lookup, where you can create a very, very small cache, so you don't have to loop through things. But I don't know, the usefulness of that is pretty small. All right. So thank you for watching, and I'll get back to doing regular things here in non-programming. Yeah. Let's see if I will jetson this, and what we'll get then, we'll get this like plus plus and minus minus. That's my goal is that basically we get the A plus plus minus minus, so, and it's wrapping around. So that's a special behavior. Then everything else around the enums doesn't work, right? You can't add it to it or something like that. You remove those, and you have to convert it and do the costs. And that's just going to be very consistent then, and it reduces the amount of code. We already have like the pointers and the vectors, which is kind of a pain when you have to do like the vectorized pointer changes, but that's kind of fine, right? Because you kind of have to do that. It's a nice thing. You can do actually you can kind of dereference things from those pointers in a nice way in parallel, but there is not such a great value for enums to have that. since you can go to the actual underlying value. And then you have the const now. So you didn't used to have the const, and then like being able to apply this thing on both, const enums and enums was a good thing. Now we have const f, so if you want to have like just treat it as a number, then you have a const const f, and that's just going to be like a number. So this should not affect const f. So if I have like instead, if I have instead const f, then definitely this should work, right? Plus 1, right? Let me just check that works. I didn't break that, but this should definitely work because now this is just a number, and since it's just a number, just it has no checking or anything that it remains a valid value. So this is completely fine, and we can go out of bounds for this. It doesn't matter. So that also makes things easier, by the way. So right, like this is definitely easier than the other one where I'm converting back and forth. So I think this should work, right? Let me just see if it doesn't work out. I need to know. Yeah, it works, right? So compare this to the Enum ones. I don't remember if I showed you. Well, I did show you. Yeah, some version on the rail here, I think. Right. So we had this snake, right? So here it is, like from ordinal and casting back and forth, right? So because you can't do mod on an enum, so if you get this next value and then do a mod on that, it's just going to change it. So whereas with the const f, it just falls out is in very easy mod way. So you don't need that, like anything extra for that. Okay. Thank you, and I guess I'll stop now. I just keep saying that I will, but now it's real. Have a nice evening, and thank you for watching. Oh, someone, am I allowed to report a bug or ask a question on stream? Yeah, you can ask. You can do whatever you want. Feel free. What's the bug that you have? You have to be fast now. Let's just close down. Oh, okay. I'll give you like a second. I mean, you're completely smart fine. If you're leaving, just see bugs on the Discord. Okay, now I'm intrigued. So there's a bug apparently. So let's see here. There regression with the current head. So emit still library no. So usually I don't require this function, but now when I'm building, I get a linker error. So they're getting whoa, undefined atomic compare exchange. You get a lot of atomic compare exchange. Whoa. I wonder what that happens. So that's interesting. I think so the issue here is getting some a symbol getting it's being undefined and it's using and then compare exchange 4 and 1 and 2, and there should be just one of those anyway. So let's look at those. So do you have the atomic? Oh, let's see here. Compare exchange. So there we go. So here we go. So here's the thing. Here's this is supposed to be weak, right? And it's no strip, and it says a CNAME. So this one here ought to be stripped from the code when I use no cdlib, right? Should be. I mean, it's in compiler RT, and yeah, but it should be included. I don't know if there's is there another version of this or something? There shouldn't be. I like. Do you have to look up your code in case you accidentally have the old standard library or something? Because there's another of these atomic compare exchange. So if that one is if you're using some old code, then that's easy. It's like an easy way to fail. It's include when looking at this which is weird. I don't know what's trying to like. So if you have duplicates of the standard library, that could certainly happen. That could certainly happen. So it should be a weak symbol and it shouldn't be repeated. If you have problems with this, the best way to is do an emit LVM, which will give me a lot. Will give you a lot of files. So if you look at, for example, let me find some example here. Right, so in resources, I was just randomly compiling stuff. So we have this ASM here, yeah, but the easiest thing to read is the LVM one. So here we go, like here I have all these LVMs files. So if you send me this, we can figure it out, because what it will do is that it will basically create like links to things it uses. So let me show you an example. Oh God, the debug symbols are so many. So yeah. Okay. Somewhere at the end there's something. Okay, I guess that. Yes, when I did that. So look at this. So there are declared. These are the four declared functions symbols in here, right? And you will get those in everything that you do. It's just basically declaring what's in some other place. And what happened for you is that you seem to have gotten that particular symbol in a lot of places, and then it's also not properly weak. So we can see what happened if you just give me that. Right. So we can grab that from Discord, and but basically it's what happened is that it tried to use that function, and it got that function from somewhere. If you use like no-std-lib, it will still give you this atomic RT, and that's a change that we did. The reason for that is that without it, you won't get everything that you need. So it should contain like the math RT here. Let's see if it gives you a bunch of those. Let's see here. And right here we have DFT, TI. I don't think these are the ones that you are seeing. So these are intended for VASM, for example. So it really does have this. Let me see what you got. So okay, you hang on, you wrote on the Discord, right? So you got like add df3. Oh, it's in run. Yeah, it's referenced in round even. So maybe that's not in your. Maybe that's missing. It could be something like that, but it does seem a bit odd. So let's see here. There's also the in math we have some of those functions. So what's it called? We actually might actually move these helper files somewhere else, like the ones that are implementing things that are needed. I can't rely on libc, but they don't seem to be there. So there's deprecated things, I guess. Those are not in use. So I can definitely see you having a round even, and the round even, like, hang on, like risk 32, you're not probably not having like integer division or something is missing, right? So it doesn't have. I don't think it has like you are compiling for a risk 32 without any integer division or something like that. Could that be it? Add double float. It looks like it's adding two floats. But the weird thing is like the atomic exchange, because that one should seems to be doing weird stuff. So do send me this and I'll have a look. All right. Okay. So in general, trying like when you we should have something that disables, round even if you don't have floats. So that's it's kind of hard to actually, you're supporting so many different things, and the language is like no, the risks 5 thing is like no, and everyone is using the emulators for it, and no one really has one, but you get like all these, like everyone wants to try it because it's like new, right? It's kind of fun, but then no one has the processors actually use them, so that maybe you should not focus that hard on those. But it's fun. It's fun. I like that people are spending time like working on that as well. I didn't do much, so mostly I'm just fixing things that are more general. So I'm really super happy about the work it's been done, and yeah, I couldn't have done it without the help of people. So yeah, I see Manu is online. He was one of the. He has been helping out a lot. That's been being great. So he and others have been helping out, and that's the way we close the bugs and make these features very solid. And yeah, I should have taken. It would be fun to do optimizing those benchmarks as well. The benchmarks that Mani did, the quick conversion of all the benchmarks that we have for this benchmark shootout. I did one fix, improved one, but I don't know what the state of this is, like if it's ready to be, pushed to the main repository. If we should get it better, some of them are not very optimized. So it's a fun thing to do, and I was thinking like maybe I shouldn't do it. Maybe should like give that to the community to have fun with, It's bad to do like me doing everything. I would like to work on my game base actually. So and yeah, I had this start when I started replacing parts of it with C3. So it would compile C3 and the rest of the thing. But I kind of lost my setup, so I should really get back to doing that as well. I mean, just the time is I don't have infinite amount of time. It's really weird. It's almost as if I have to go to work and do work stuff too. Well, okay, so enough of that. So I'm doing embedded dev on a RISC-V processor. Oh, is that like so? Like, it's fixed. I put use diddlib no. If I put use diddlib no, I'm not using any float code. Yeah. So we should make sure that when you use a diddlib, there should be an option, not to have any floating point RT. So that's just a setting. So tell me that it should be fixed, and we could probably fix that because we don't want like a really emulated floats on a RISC processor that doesn't have floating point. I don't think that's a great idea. Okay, so anyway, so have a great evening again, and thank you for watching.